In 1997, Ian Stewart published his book called Nature's Number. And in that book, we got a glimpse of how a mathematician views our natural world. But one chapter really caught our eyes.
Throughout human history, two views have been formed about how we see nature. One says the universe obeys predictable and changing laws. It's neat, it's orderly, it's like clockwork. The other, it says nothing is constant. Everything is always shifting, flowing, becoming. As the Greek philosopher Heraclitus put it, you can't step into the same river twice.
Science, it's mostly been team predictable laws, but these days things are changing fast. And maybe the old flowing river idea is making a comeback.
Let's talk about the constants of this reality and how they generate change and alter the findings of the class. Now, we are going to dive deep into the constants of change. Come on!
We're taking it back all the way to the Renaissance. Picture this. Newton is sitting under a tree. An apple falls, and boom, he discovers gravity.
Yes, but he didn't stop there. Along with Leibniz, Newton co-invented calculus. Yes, calculus, every student's favorite class, right?
Here's where it gets cool. If you know just one of these, position, velocity, or acceleration, you can use calculus to figure out the other two. They're all connected.
When you plot the position on a graph, you can see how it changes over time. The velocity curve shows the rate of change of position. Lastly, the acceleration curve represents the rate of change of velocity. All three are interconnected. Understanding one enhances understanding of the others.
Now, let's write the wave literally. The wave equation shows how the height of a wave changes over time. And what's that again? Change equal differential equations.
Yep, that's calculus in action. And it doesn't stop at waves.
Differential equations are everywhere. They describe how populations grow, how diseases spread, how money grows or crashes.
Let's zoom out even more. Outer space? Anyone?
So the Earth, is it just floating in the middle of nowhere? Is it magic?
No! Gravity! Newton's law of gravitation explained all this over 300 years ago.
He cracked it using, you guessed it, differential equations again. From falling apples, orbiting planets, it's all math.
And these aren't just fun facts, they're part of a bigger idea. Even though things are changing, the rules behind the changes stay the same. But things got tricky with more than two objects. The three-body problem was a beast. No exact solution, just messy approximation.
One guy, Charles Tilano, spent 20 years writing a single approximation of the moon's motion. That's commitment.
And it didn't stop there. Even computers struggle with problems like bin packing or finding the shortest superstring. But instead of giving up, we learn to work with approximations.
And that's the point. Math doesn't always give us perfect answers anymore. It evolves with our understanding.
Then came chaos theory. In 1994, Ziyong Xia proved that three-body systems can drift slowly and unpredictably over time.
This phenomena, called Arnold diffusion, showed us that sometimes there's no neat formula at all.
But chaos isn't just randomness, there's structure in it. Systems like double pendulum, Lorentz attractor, and even weather patterns have strange but real order.
So now, solving doesn't just mean finding a formula. It can also mean predicting behavior, recognizing patterns, or even just understanding how something changes.
And that's not a step back, it's a step into a deeper understanding of reality.
Overall, Ian Stewart's Nature's Numbers doesn't just explain equations. It gives us a whole new lens to see natural world.
Stewart explored how constants like gravity or calculus help explain change, from the movement of stars to the growth of a tree.
He showed the meaning of solving problems has evolved with time, just like how our universe do.
More than numbers, Stewart encourages us to listen to nature's patterns and see math as a creative, evolving language. And with that, we can truly say constants generate change.